we use semiconductor in forward bias condition. But what happens when we increase the reverse bias voltage? Can we increase the reverse bias voltage indefinitely and will still get the net current equal to reverse saturation current? Well, this is not the case. That's why I said I0 is called reverse saturation current, because theoretically it is saturated current value which will not increase on further increase in the voltage. However, practically the scenario is quite different. When we apply high voltage, then junction breakdown phenomena occurs, as per which after a certain voltage, say breakdown voltage, the current increases very sharply even for a small increase in voltage. For a normal diode, it is an undesirable effect, as high reverse currents in the junction lead to heating effects which ultimately destroys the junction, which sometimes even lead to permanent destruction of diode. There are mainly two types of breakdown mechanism: Zener breakdown and avalanche breakdown. We will talk about Zener breakdown in this lecture and will discuss about avalanche breakdown in the next lecture. Zener breakdown occurs when a junction is heavily doped. The energy bands in such cases cross each other at relatively low voltages. Crossing of energy bands mean that minima of conduction band energy level of the N region is lower than the maxima of valence band energy level of the P region, such that few energy bands of the valence band of the P region nearly coincides with the energy band of the conduction band of the N region. You can see valence band in p-type region is having higher energy level than the conduction band in the n-type. In such cases, tunneling mechanism occurs, in which electron moves from the valence band from the p side to the conduction band in the n side, which constitutes a reverse current from n region to p region. This effect is also called Zener effect. The tunneling mechanism is facilitated by a huge number of electrons separated from a large number of empty states by a very narrow barrier of finite height. It is very important to have sharp metallurgical junction and high doping so that chances of tunneling increases, leading to Zener breakdown. The electric field required for this type of ionization is of the order of 10 raised to the power 6 volt per centimeter.